Hello again. So today we continue our study of arrays. So last time we were still working on simple one-dimensional arrays. Today we look at multi-dimensional arrays. So let me show you an example from the lecture slides that are already uploaded. What multi-dimensional array, what kind of data it can store. So this is an example. This is something called a distance table, which tells us the distance between 2 points, 2 places on a map. So let's say we have a couple of places. We have these US cities: Chicago, Boston, New York, Atlanta, Miami, Dallas, and Houston. And we're interested in storing the or want to tabulate, store the distance in miles from one city, from any one of these cities to any other city. So one way to do that is by keeping that information in the form of a table like this one. You can see that if you want to keep this information in a data structure inside as part of a program, um, a one-dimensional array is, you could do that, but you could have a one-dimensional array for each city. So the distance of each city from one city to all the other cities in one array. So basically keep one row of this table in one array, one separate array. That would be one way, but a better way would be if we perhaps had a single data structure that could contain all of this information, kind of like the way we are seeing it over here. And of course, there's a way we can use something called two-dimensional array. And that's basically what we'll spend much of our time on today. Now, arrays can be two-dimensional, but can also be three-dimensional, four-dimensional, can have as many dimensions as you need. But for the examples that I'll show you today, we'll be working mostly with two-dimensional arrays. So there are a couple of things I should know. So this is how we declare an array. So this is just a very general form. There's not even an example. So the name of the data type. So if you want, so all elements stored in an array have to be of the same data type, of course. They have to be either all integers or all double precision floating point numbers or floating point numbers or characters and so on. So the data type goes over here. And for a two-dimensional array, we put not just one, but two two pairs of square brackets. After that, a space, and after that, the name that you want to give to that, to your new two-dimensional array. So this is how you declare an array called reference variable, I guess. Now, this is just giving a name to that array. You haven't created, you haven't built that, you haven't allocated the memory for that necessary for that array in your computer's memory yet. So you also have to create an array, and this is the second step. This is how you create an array. So the name of you assign. So you allocate new memory using the new keyword. You specify the data type, an integer, of course, so you have to specify the same data type again. And over here, you have to provide the size of the two-dimensional array. So in this case, this is a 10 by 10 two-dimensional array. We'll see what we mean by that in a minute. But this is basically an array or a table. Think of it as a table that has 10 rows, and each row has 10 entries or 10 columns. And this newly allocated memory is given or can be referenced or can be accessed by the name, by the reference over here, this one, which we already declared in the previous line. Now, as you can see, this is a two-step process, but you can also combine both these steps in a single process, like we have been doing for one-dimensional arrays. And this is what both these steps, you could combine them into one, and you could do them in a single line. So data type, uh, the name that you want to give this two-dimensional array, and then allocate the memory on the right-hand side of this assignment operator. Uh, Here's an alternative way or an alternative syntax to this. Instead of putting these two empty square brackets right after the data type, you can also put them after the name of the array. Uh, Either way works. Both are fine. I usually like to use the first one, the one that I underlined. This simple piece of code that is an example basically. So this one over here is how you declare and create an integer array of size 10 by 10. Uh, this is how you put a value, the number 3, into the element of this two-dimensional array that we call matrix into location 0, 0. Now, and over here in the next 3 lines, this is how you go through the entire array, and you put in random numbers between random integers in the range 0 to 1000 into each element of that array. Now you can visualize a two-dimensional array like this, basically a table. The first element is the one with index location 0, the row number, and 0, its column number, so 0, 0. So which means that this location over here, this element of the array has index 2 because it's row number 2 and column number 1, so its index is 2, 1. And over here, this is how you would assign the value 7 to this element of array matrix. All right. So make sure you go through the slides before you watch the video, I guess, or let's definitely go through them before you come to class. There's always more explanation in the slides that I upload. Okay. So let's do a practical example. Okay. Switch over here. I already have a blank project. Save us a few minutes. Okay. Let's see what we can do over here. So let's try out some of these things. Let's start with the very basics. So we'll be using a lot of loops. So let me declare some loop variables, I and j, loop counter variables. And let's start by creating our first two-dimensional array. So I used to call the one-dimensional arrays A. Because this is a two-dimensional array, I'm going to call this A2. Okay. All right. Actually, let's do this in one step. So, okay, so in 2 steps, I could write this. So this is the 2-step method. Separate declaration and creation of the array. Or I could do the whole thing. Or I could do the whole thing on one line. Simply like this. Both will do the same thing, and run it either way. So no reason to do so. It's important for you to understand that there are 2 things happening, and you can break it down into 2 separate lines, but usually you can do it in just one line. That's fine. Okay, So let's write some random numbers into this two-dimensional array, and let's also print out the array. Let's do both things, and we can do that uh, together actually. Um, so let's, let's format the output to make it look nice. So we have, we'll use two loops, of course. The first loop, so this array over here has 4 rows, 3 columns. So the outer loop will count the rows. Okay, so I have 4 rows, so let me just hard code this for the moment. And the inner for loop will count columns. Okay. So I'm just hard coding this right now so you can see which of these two loops is doing what. And I'll be doing more than one thing. This for loop. And see. All right. All right. So over here first I write a new value to an element of A2. So I'm going to cast this to an integer. We're going to use math.random, of course. And I'm going to scale this up to the range 0 to 100, just so we don't have to deal with fractional numbers. And I'm going to use the same loop to print out the value that I just assigned. Okay, and after each row, I want each row of the array printed out on a separate line. And there you go. Okay. Okay, so we are declaring and creating an array of size 4 by 3. That's how we read that, 4 by 3. And then we are initializing all the elements in that and printing them out. Let's run this and see what the output looks like. There you go. So as you can see, we have 1, 2, 3, 4 rows, each containing 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3 elements. So 3 columns. This is what a 4 by 3 array, this is what our 4 by 3 array contains over here. Now, we just initialized this array A2 randomly, but remember, for one-dimensional arrays, we had another way. We could also manually or initialize arrays. So kind of like this. This is what we did before for a one-dimensional array. Integer array B1, and if I already know what values it and what values it's supposed to contain, I can just write this. Okay, and if you want to make sure, so let's print this out as well. Let's make the output look good. This is array B1 because it's a one-dimensional array. There you go. For loop over here that will go through all the elements. I less than B1 dot length. And system dot out dot print B1 at I. Also pay attention to how I am indenting the code. Okay. Saw in class that while many of you manage to complete the task itself, um, many of your indenting was horrible, actually for most students. So pay attention to how I'm doing it. There you go. Okay. So B1 contains 100, 200, 300, 400, 500, like I specified over here. But we can do the same thing for, we can initialize two-dimensional arrays the same way. Let me show you how that looks like. So let's say we have two-dimensional integer array. Let's call this one B2. This is kind of like the counterpart to this. And pay attention to this. This is slightly different now from what you've seen before. Okay. So I'm going to, you could put the entire thing on one line, okay? This is just a little more readable, so that's why I'm doing it this way. So basically, this is how I'm going to make B2 a 3 by 3 array. Each line is going to contain 3 elements, 3 numbers, 3 integers. Take a look at that. So B2 is an array, and over here are its contents. Its contents are basically, you can also think of the contents as 3 one-dimensional arrays, 1 on each row, and each containing 3 numbers. Now, I'm going to make sure this actually works. Let's print this one out as well, and I'm just going to take the code I already have for printing out two-dimensional arrays from A2. Let me delete that. This is the random initialization. Don't need that. Okay. Don't need that. Okay. Remember, when I have only one statement inside a for loop, I don't have to put those parentheses before and after the statement. Okay, that's what I'm doing over here. I just think it looks a little more elegant. All right. Okay, so this is, of course, we are printing out B2. It has 3 rows, 3 columns, B2, and I think that should do it. Okay, let's take a look. There you go. And here is B2, 10, 20, 30, 40, 50, 60, 70, 80, 90, need each row printed out on a separate row over here. Okay. Okay. What else? Oh yeah, another important thing. You've noticed that in these loops, in these nested loops, in which I'm printing out the elements of array A2, and in the nested loops in which that I'm using to print out all the elements of B2, A2 and B2. Um, I hard-coded the numbers that specify the number of rows, the number of columns uh, that I'm going through. It's not like uh, uh, we didn't use this length property of arrays to when I was writing these loops. And the reason is, the first question, of course, is what does length even mean when we're talking about a two-dimensional array? So let's go back to array A2, the first one but that we made, this one up here, and that we initialized with random numbers. So this has 4 rows and 3 columns. So the number of rows and columns is different in this example. In B2, rows and columns are both 3 by 3. So let's go back to A2 and let's see. So system dot out dot print. Let's see what is the value of what is A2's length if I try to access that variable. All right, that property. So A2 dot length. I'm just going to make sure this looks nice again. We know what we're looking at when we see the output, and I'm going to print out A2 dot length, the value of A2 dot length. As you can see, I'm not getting an error or anything. It seems so. A2 dot length does exist for A2, even though A2 is a two-dimensional array. Let's see what it is. Let's see what its value is. Okay, let me run this. There you go. Print line. There you go. So A2 dot length is equal to 4. 4 happens to be the number of rows of A2. See, this was A2, which had 1, 2, 3, 4 rows and 3 columns in each row. So when you call A2 dot length, you get the number of rows of that two-dimensional array. Or, if you want to look at it over here, you get the first dimension of your multidimensional array. So if you can get the first dimension of your array using the length property, is there some way we can maybe also get at the number of columns, the second dimension of the array? And as it turns out, yes, we can. Let me show you what that looks like, how we can do that. So let's say I want to know what the number of columns of the first row of A2 is. So I can access that using A2 0. So A2 0 means row number 0 of A2 dot length. As you can see, if I run this, the answer is 3, which is correct, of course. I have 3 entries in row number 0, this one, of A2. And guess what? Just as easily, I could have looked up the number of entries in row number 1. And I could have just as easily looked up the number of entries in row number 2 or row number 3. Now, all those numbers in this example are of course going to be the same. All rows contain 3 elements. So it doesn't matter which row if I want to check the number of columns, I can access really any row number. I can provide any row number of A2 over here, and I'll get the same answer, 3. kind of makes me curious. Is it possible to have a two-dimensional array in which every row contains a different number of elements? Let's try that out. So let me create a two-dimensional array C2, C2, okay, and it's going to be a lot like before. And let's try something different. And I'll put in the numbers, let's say 1000, 2000, 3000, 4000, and in the next row 5000, 6000, 7000, and 8000, 9000, and 10,000. I'm trying to create an array, a two-dimensional array that has four elements, that has four rows, but has four elements in the first row, three in the second, two in the third, and only one in the fourth and last. Let's see if this is even possible. Looks messed up. So I just run this. If I don't get an error, it means Java is okay with it. Aha, no error. So while we're at it, let's print this out. And let's print it out using a loop this time, because we now know how to get to the number of elements in each row, right? Okay, so the number of rows of this can be accessed by C2 of length. So this will work. The outer for loop will go through the number of rows. The inner for loop counts the number of columns in every row it is in. And we can access the number of columns by C2, whatever column we're in, whatever row we're in, dot length. This should work. Let me try this out. There you go. Take a look at that. C2, 1000, 2000, 3000, 4000, next row. 5000, 6000, 7000, next row. Just 8000, 9000, last row, 10,000. And we are using or picking up the number of elements in each row using the length property of each row. Now, all of this is already in the slides. As you can see, this is without too many practical examples, two-dimensional arrays, how to initialize them. And this last array that we just worked with does actually have a special name. It's called a ragged array. Ragged means when things are unequal, kind of like the heights, the lengths of the fingers on your hand. They're all of unequal length. You could say that they're ragged in a way. Okay, so there's a bunch of examples included in the slides. We did some of them right now. So initializing arrays with input values. So this Second example here at the bottom is one in which you're initializing elements of a two-dimensional array with random integers between 0 and 100. That's kind of what we did. Here's an example of how we can go through, again, nothing to it. You've already done this for one-dimensional arrays. Actually, yeah, we did this in the last lecture. This is how you can sum up all the elements in two-dimensional arrays, basically just two for loops, some variable. So we'll do something like that in class, actually. Random shuffling of numbers in a two-dimensional array. And let me see what else. And yeah, so make sure you go through these. There's a nice application, example of an application. At the end of the lecture slides I uploaded, basically a simple program that grades student tests for you. Take a look at that. Code for that is given. Okay. And so next time we'll talk briefly about multidimensional arrays of more than just two dimensions. But basically a brief hint, this is how you can create a three-dimensional array, in this case of double variables. This one having 10, this one of size 10 by 5 by 2. You can think of this as a one-dimensional array of 10 elements, and each element is not just a double, each element is a two-dimensional array of size 5 by 2. So anyway, we'll talk about that next time. All right. See you all tomorrow in class.